Hello, I'm Robert, science blogger and fact checker, and helping the scared people on Facebook in Doomsday Debunked. And this is about the whole idea that the Arctic is some kind of tipping point, which is it's junk science, and it's a sociologist, a sociology professor who's a little bit nutty for the Extinction Rebellion, and he fancies himself as a climate scientist, and he isn't. And so this is what he actually says in the Extinction Rebellion handbook. This is not a drill. He said, "I'm a social scientist, not a climatologist, so who am I to spread panic and fear?" I mean, exactly. And then he says, "Once I realised that IPCC couldn't be taken as climate gospel, it's not gospel, it's science." And he doesn't seem quite understand how science works. He goes on, "The Arctic looms large. It acts as the planet's refrigerator by reflecting sunlight back into space and by absorbing energy when the ice melts from solid to liquid." And he says, "Once it's gone and the dark ocean starts absorbing sunlight, additional global warming blows the global 2-degree warming target out of the window." And he's so convinced, he goes on and says we should be seizing and brightening the clouds above the Arctic immediately as a global emergency response. You can read that just now. You could go and buy their book this is what the Extinction Rebellion are telling everyone. This is not peer-reviewed science. It's just a sociologist riffing on ideas from his own imagination, and that he's got from junk science books, blogs. So this is the true situation. This shows how much the brightness of the planet has changed since 2000 to 2012. And you can see where it's red and orange, then it's increasing amount of solar heat is coming in because it's less reflective. And then where there are more clouds, there's less heat absorbed, and that's the blue and the green. And you can see that the large areas that are red and orange, not just in the Arctic, but in other places, and the large areas that are blue and green. And it's not immediately obvious which there is most of, but if you do the adding up, which they did, if you do the maths and average it and integrate it over the entire area, then the world is actually getting brighter and more reflective as it warms up. It's the opposite of what he's talking about. The Arctic is one particular region that is getting less reflective, so are areas in the tropics. And that's how much heat it absorbs. It's absorbing more heat there, and it's absorbing less heat there. And so what he said there, it's just wrong. There's no two ways about it. It's not based on science. It's just it's based on knowing that it is getting slightly darker in the Arctic, but there are also lots of clouds in the Arctic as well. And the more clouds as the oceans get covered, and the amount of that is getting less bright there is more than compensated by the rest of the planet. Even the northern hemisphere is more than compensated for. So this is just wrong. It just made a mistake, and it's an absolute daft idea anyway to try and reflect light in the Arctic, because the sunlight is coming in from a very low angle if you're in the Arctic, even in summer, and do nothing in winter. If you wanted to reflect light away with some kind of reflective layer, you do it in the tropics. I mean, just totally bonkers idea to put artificial clouds in the Arctic in an attempt to cool down the planet. If you did want to do that, and we don't need to do that, and it's something you do with great caution because it can affect weather patterns and things. But if you did want to do it, you do it in the tropics where there's sunlight coming straight down from above, instead of there where you've got the sunlight coming from the side, and you just couldn't get a bit of it blocked, and only in the summer. So he's just not a scientist, he's just a sociologist. So don't listen to these people, they're bonkers. And this is another article, which was, this is an article, this is not his article, this is a climate scientist tweeting and saying this article is ridiculous. And this is about an article that used Jem Bentel as one of their sources right at the top of the article. And that's my thing, I replied there as well. And the IPCC, so this is what I just explained to you just now is the consensus of science. It's moving towards a consensus. So sea ice is often cited as a tipping point, but detailed modelling suggests that summer ice can return within a few years after this artificial removal if it got warmer. And the studies suggest it's neither irreversible nor is it a bifurcation, which means it comes back that it's harder to reverse than it is to go up. And it's plausible that if we were to go overshoot and then reduce the CO2, and by the end of the century just quickly re-equilibrate back to the way it is now. That's what the science says. And then some people will say that it's warming faster because the ice is melting, and the melting ice, and so we know the Arctic is warming faster, and some people will say this is why it's warming faster in the Arctic, because of this change. But actually it's not. That's quite a minor effect. It's not big changes. And the main reason is because you got more convection, and this is a planet completely made of water. Then you get more convection, just a model planet, not a real planet. But these planets may exist out in the universe. Just no ice, no land, just water. If it's got a very deep ocean, then this is what you get. Then, as it warms up more in the equatorial regions, and it warms up an awful lot more warms up most of all in the higher latitudes. There's a little gap in between. This is a water planet. So it's nearly twice as, it's 3 to 5, just pure water planet. So it's a similar effect to that. And so we have this polar amplification, and it's quite in our world, just the way it is. There's very little. There's lots of high mountains there that stop winds that would prevent the heat from convecting. You get a lot of convection that goes that way, from the equator to the northern hemisphere. When it comes to the southern hemisphere, then we've got these winds that go around the southern ocean, and these stop the convection from the equator down to the south. You also have an anti-greenhouse effect over Antarctica, which is that I don't know if I should quickly explain that in another video, but to just quickly explain, the greenhouse effect is actually, if you think about a thermos flask, then the thermos flask keeps your tea inside warm by the outside being cool. And it's the same with the greenhouse layer. Our greenhouse layer, high up in the atmosphere, and we have two layers, one for water vapour, another for carbon dioxide, much higher, then it's actually got to be much colder than the surface. And the surface, if it weren't for the greenhouse layer, our average temperature would be minus 19. In order to keep the surface warm, we have a layer of about that average temperature, very high in the atmosphere, about that minus 19, that the surface would be otherwise. And the surface heat, if it just radiates up to that layer, is trapped by it, and half is radiated back down, half radiated into space, and that greatly increases the surface temperature to about 15 degrees centigrade. So in order for that to work, the greenhouse layer has to be colder than the surface. And so a lot of people have this completely wrong, and they think it's convection, and they think that it's a warming layer. And that wouldn't work. If the greenhouse layer was warmer than the surface, the planet would cool down faster, and so it would actually have a cooling effect. The greenhouse layer is cooler than the surface. Now, over Antarctica, the greenhouse layer is cooler than the Antarctica gets so cold, especially in winter, it is cooler than the greenhouse layer. So the more carbon dioxide you have, actually, the colder Antarctica gets as a result of the greenhouse effect. You've got this reverse greenhouse effect that actually cools it down as you add more carbon dioxide. And then you've got this bit of convection, and then but the convection is stopped by these big strong winds. And then there's also an ozone layer effect as well. When you destroy the ozone, it also has an effect, because ozone is I can't remember, but I have to look that up. But the ozone actually warms it up, and then if having a bit less ozone also cools it down a bit. So there's several reasons why Antarctica is not responding in the same way that the Arctic is, and none of them is really much to do with the albedo effect, even though it is brighter. But the albedo effect is a minor thing, and it's not one of the major reasons why Antarctica is not warming up in the same way that the Arctic is. It's mainly these other things. It's the trade winds. Trade winds are the strongest one, and the big strong winds that are stopping the convection, and you get the strong convection into the Arctic. So this albedo effect is just it's not science. It's wrong science. Science is these people who do sociology and philosophy. They kind of think it's like politics or something, that anything you say in science is all right, and if you make up some idea, and it seems kind of plausible, then in philosophy it does work like that, and in politics, you make up different ideas in politics, and I mean, it's political science. I presume that works differently, but in terms of actually arguing political agendas and things, then you can have lots of ideas and thoughts, and there's grounded in facts, but there's a much stronger element of just actually being able to invent and go off in your imagination and persuade people through the power of your reasoning to do certain things. But science just doesn't work like that at all. Your ideas cannot influence the world to behave in a different way. No matter how much he talks about the Arctic, it's not going to make the Arctic warm up, no matter how much he says it will. No matter how much he says that the whole world is warming up, it's not going to make it happen. So words work very differently in science. In science, it's very evidence-based, and if your words don't fit the evidence doesn't change, the world doesn't change, you're just wrong. And I think maybe sociology and philosophy, it doesn't quite work like that, and they maybe don't quite realise how little power your words actually have if you're talking about science. If what you say is wrong, and this is just wrong. There's no evidence, the evidence is against, and the Earth as a whole is actually, the albedo effect is actually cooling in its effect. It's just slightly helping us. So that's all I want to say there. This whole thing is just wrong. It's just not science.